Hello everyone, this will be a short video on limiting reactants, also known as limiting reagents. Okay, so I will be like most of my colleagues and I will start with an analogy, and hopefully mine's a little bit more silly than my colleagues. First of all, I'll tell you what it is. We'll use an analogy and then we'll do an example, and then finally I'll upload some samples for my students to look at. Obviously, if you're not my student, you won't have those samples, but I'm sure your instructor will give you the version. Okay, so what's a limiting reactant? It's a reactant, funnily enough, that limits a chemical reaction. That limits the progression of a chemical reaction. How does it limit the progression? It limits the progression because it runs out. Now, obviously, if you're an English language learner, I probably shouldn't have written runs out, because then you would imagine who's running out of the room. So I apologize for any English language learners. I mean, it expends itself. So I keep forgetting to not use vernacular language. Not tends to, I'm being all mathematically here. Reaches zero quickest. Zero quantity. So it just runs out, reaches a zero quantity. Okay, so let me scroll down. Let's continue. So my silly analogy, and it's not an analogy if it's not silly if you ask me, but we're going to consider a bacon sandwich. So and this is even, what's the only thing in this planet better than a bacon sandwich is a bacon and egg sandwich. Consider a bacon egg sandwich. So my bacon egg sandwich is going to have one bacon and one egg. And if I want to make my perfect bacon sandwich, that's going to make one sandwich. One sandwich. Okay, so that's my perfect bacon egg sandwich in this analogy, at least. Okay, so there's a question. How many bacon egg sandwiches can be made from the following ingredients? Okay, so I'm going to add some ingredients. Let's change the color of the pen just to keep it interesting. So I've got, that's my string of bacon. So I've got 2 bacon, and I've got pretty good looking egg. I've got 3 egg, and the question is, I get how many sandwich? Okay, so that's my setup. So we're going to answer this analogy using the same technique that we will do our real chemistry questions with. So let's put our answer on this page. So again, just in case you need to look at the question, if you pause in the video, I have to remember to freeze what I'm doing so that if you're watching a video, you can take a look. So that's our question. We're going to use our bacon egg sandwich recipe to actually solve the problem. Okay, and this is the setup for solving the problem. Okay, we have to consider both ingredients. So we're going to consider our bacon first. We're going to do a dimensional analysis calculation. We're going to calculate number of sandwich. So we write sandwich. And we know from our balanced equation that one sandwich is equal to one bacon. How do we know that? Remember, from our equation here, everything here is equal, so one bacon is equal to one egg, one bacon is equal to one sandwich, one egg is equal to one sandwich. Okay, so that's where we're getting this ratio from. So one sandwich is equal to one bacon. So I can put bacon as a preceding object. And now I want the input of how many bacon I had. Well, in my question, I had 2 bacon. And just to remind you, I had 2 bacon here. All right, so 2 multiplied by 1 is 2, divided by 1 is still 2. So based on the bacon, I can make 2 sandwiches. Let's now consider the egg. Okay, we're going to do something similar for eggs. We want to calculate how many sandwich we can make from our egg alone, or how many sandwiches would our egg like to make. One sandwich is equal to one egg. And we have egg here, and we were given, in our question, we were given 3 egg, right? So we've got a 1-to-1 ratio with our sandwich and egg. That came from our recipe that we were given initially. And our input was 3 eggs in this particular problem. Okay, so 3 egg multiplied by 1 sandwich is 3, and divided by 1 egg is still 3. So the eggs would like to make 3 sandwiches. So we've got 2 answers, because we had 2 things with an opinion. So the options were 2 sandwiches or 3 sandwiches. Two obviously is less than 3. So the lower quantity is always produced. So you have to look at both alternatives if there are two knowns, I guess, which we had in this problem. You have to look at both options. And you have to see which is the lowest of all the options, and that's always called the theoretical yield. So the lower quantity is always produced, and it's called the theoretical yield. And it stems from the limiting reactant. So the limiting reactant produces the theoretical yield, which is the lowest quantity, and the limiting reactant on this occasion was the bacon. because it's the bacon that led to the theoretical yield. The larger value, and I won't circle it, but the larger value comes from the excess quantity, and we can just ignore it. So all of our calculations come from the limit and reactant, and that's why it's vital that you can determine the limit and reactant. Okay, so that's our silly analogy, but tasty analogy. Let's look at a regular chemistry example. Okay, so we've got an equation, C3H8 and 5O2, so I'm going to balance it for you. 3CO2 and 4H2O. So this is a combustion reaction, combustion of propane to give carbon dioxide and water vapor. Okay, and the question says, if 14.8 gram of propane, C3H8, and 3.44 gram of oxygen react, let's see, how much water in grams is produced. Okay, so this will be the only chemical example I'll have in this video, and then I'll just post some problems with the answer keys for my students to work through and alert me to any issues. Okay, we've got two knowns. We've got the propane and the oxygen. Now here I've specified a target. The water is my target. If a question doesn't specify a target, you can just pick any product and compare the same product for both competing reactants, as long as you compare like for like. Okay, so let's start with our propane. So C3H8, we're going to have a dimensional analysis. And I'm looking at grams of water. So I'm going to write gram of water. All right, well, I know from adding up the mass of 2 hydrogens and 1 oxygen that there's 18.02 gram of water in 1 mole of water. So I can promote mole of water like that. I know from my balanced equation above that 4 moles of water is equal to 1 mole of propane. So just to remind you, that's coming from here, this 1 to 4 mole ratio given in the question. So I can promote mole of propane up here and cancel. I know from help with the periodic table, if we add up the 3 carbons and the 8 hydrogens, 1 mole of propane is 44.11 gram of propane. Gram of propane. And then my input was 14.8 grams of propane. So I multiply 14.8 by 1 by 4 by 18.02, and then I divide by 44.11, divide by 1, divide by 1 again. I get 28.18. I add an extra couple of insignificant digits, so I'm given an extra digit here, although technically I'm stuck with 3 sig figs. I'm going to give a 4th sig fig just because I don't want to round yet. So that would give me, I'm just going to leave it like that for now. No need to do anything else with it. Let's do a similar calculation with our oxygen contender. So we're going to have a similar dimensional analysis calculation. Again, I want gram of water. So I start off the same, 18.02 gram of water is 1 mole of water. So I can promote mole of water up here. I know from my balanced equation 4 moles of water is equivalent to 5 mole of O2. So again, just remind you where that comes from. It's this 5 to 4 mole ratio between oxygen and water. Okay. I know from the periodic table the mass of 2 oxygens. That is 32 grams of oxygen. And my input in this question was 3.44 grams of oxygen. So multiply 3.44 by 1, by 4, by 18.02, divide by 32, divide by 5, divide by 1, 1.5497. So clearly one of them is smaller. So clearly that is the smaller quantity. So as soon as we have the smaller quantity, I know exactly how much water is produced because I've now got the theoretical yield. And I got the theoretical yield from the limiting reactant because the theoretical yield, or the limiting reactant rather, always produces the theoretical yield. So I know that that propane has excess. So this is my excess reactant. Okay, so the answer to my question, how many grams of water are produced? So 1.55, we'll round it now, grams of water produced. And that's how you extend our discussion of bacon egg sandwiches to real chemistry.